Okay, hello guys. Um, Today is October 16, and let's get a quick review of the machine learning today's lesson. So, like, we are talking about unsupervised method. We are learning what unsupervised method. Uh, Today is the clustering. And what is unsupervised? That is, we have no true label that we can learn. So the data is totally raw. Totally raw. You want to find some relationship between the data without labels, right? Here is the unsupervised. And how about clustering? Clustering is that like we have so many clusters, like, and we will try to like make it into two groups, right? So here will be cluster 1, here will be cluster 2. We use clustering to get clusters. Okay. So clustering is a verbal, right? Clusters is a noun. Okay. And so what kind of the method we can use to do the clustering? So firstly, we introduce the k-means. K-means means we are using the average position of the point to represent, to say this cluster, right? For example, in here, we have so many positive here, right? And where is the means? The means should be, I think it's here, right? It could be here, the mean position of S, of the positive class. And let's add a negative here. So the negative, the mean of the negative will be here, right? The mean of negative class. Yeah. So we will say this kind of mean position will represent the cluster. So when we say the C1, where is C1? We will get let's say it's a x plus and y plus, and here is x negative and y negative. C1 is represented with the x positive and y positive, and C2 will use the x negative and y negative to represent these two clusters. And how about the total algorithm is? So firstly, we will initialize the center, or you can say the mean position, and we will initial k center, k positions. So the important is you need to define this k is a hyperparameter, right? Because it's defined by you, defined by MLE. You are the machine learning engineer, right? So firstly, you will define where is the center. And for example, I say there is two cluster, so like k equals to 2, and we will have C1, we will have x, okay, x1, y1, and C2 is the x2, y2. So here we finish the initialize. And second, we will calculate the distance for each point to this kind of k centers. a notice is the center can be point position, or it's not the point's position. So it can be some of the points, some of the actual item you have, or it just a random position out of the points, out of the actual items. Okay, so here is the node. Okay, so there is why this medium, this center I get is like not the actual point, actual negative item, actual positive item, right? So we will calculate the distance. We'll calculate the distance and then cluster, do the cluster. Clustering, do the clustering. All right. For example, I have a node item in here. Okay, I mark it as a node, and you can see the distance between the positive and the distance between the negative cluster. Which one is shorter? So surely we will say it's closer to the positive center, right? So we will do the clustering and say, and assign point to closest center cluster, right? That is do the assign thing. And the 3, we will actually just repeat the 2 actually. Oh, and here is 2. We'll have the final step is to update K center, right? Because you have new points, right? With new points, I mean, you are doing the average thing, right? So with new points, your average will update. Will update, okay? So, and then you just finally repeat it until what? Until no new assignment. That is, there is no point need to be reassigned. Everyone will stay in their cluster, will stay at their group, so that you can say, okay, I finished the clustering. Okay, and here is the k-means. There is using the average, right? Average position actually, right? Mean. There is what the k-means means. So, and then we introduce k-medium. Mediate. What difference between the k-mediate is and k-mean is mediate must be real point position, right? It's a real point position. And for median, the center can be or not, right? Could be or not the real point position. So there's the difference. And the algorithm is totally the same. 1, 2, 3, right? Yeah. Just need to find in the second step. Just need to find the median point position. Okay. And so, well, how about the advantage and disadvantage of these two kind of algorithms. So like for k-means, I use the blue. K-means, the average, use a tick. We say it's easy, right? And efficient. So how about the disadvantage is not robust, right? Not robust because if we have some outliers, for example, I have a plus in here, and your median will try to get in here. The mean, your mean mean point will be here, and then your cluster will be a really fat, big. So, but actually, it's an outlier. We can actually to get our mean in a much better place. So it's sensitive to the outlier, that makes it not robust, right? Because the outlier. And the most important thing is you need to the k rely on k you define, right? So if you define a k is not that good, then your clustering will get not a really good result. And actually, there's another point is that it cannot handle two kind of circle item. Here is the A class and here is the B class. It cannot handle this kind of data, right? So these are the disadvantage for k-means. And how about k-median? K-median, actually they are shared, right? They are shared. These two are shared. Positive and negative, I think. Okay. I mean advantage and disadvantage. Okay, so these are two kinds of easy way to do the classic clustering. And then we introduce something called hierarchical clustering. Hierarchical clustering. So what's the most important is need to determine the distance. So how can we determine the distance? We have a few method, right? You can use the single linkage and the complete linkage and the average linkage, and also the words method. Okay, so what is the single linkage? That is, you have two cluster. You may have two kind of points, and we will pick the most close 2 points to say their distance, right? Yeah. So yeah, let me have another example. Okay, yeah. We will try to get the most closed 2 points from 2 clusters. So like we are saying A, B, and C, and we want to get the A with others. So which is closer? So surely A and B will be closer. So AB will be merged into a bigger cluster. That is the single linkage. And how about the complete? Complete is use the most far away point from two different clusters. And then that's actually the minimum of the max distance, right? Minimum of the max distance of two clusters. Okay. So an average is surely using the average point, right? Using the average position of two cluster, and yeah, the complete is using the most far away points of the two clusters. So how about the effect? With these three methods, the single will get a result that we may have some chain. It's kind of chain, right? Because these two are close to each other, and these two are close to each other. So we will map these two AB together, and BC and ABC together. So we will get a chain group, right? And how about the complete? The complete will use, say, the minimum distance from the max distance of the two clusters. So here is the one, here is another, and here is another. So which one is farther? These two are farther, and maybe, and then it's these two guys, these three guys together. So it will be a fat, I mean big, a huge group, right? And average will doing nearly the same thing as the K median, right? I think K mean or median, okay. And how about what method? It will need us to calculate, do some calculation, to make sure what I need to double check with it is. And so let's check about the positive and disadvantage, the advantage and disadvantage. Advantage is we no need K anymore, right? We don't need the K value. We don't need this K hyperparameter. But how about the disadvantage? Disadvantage is still sensitive to noise, and we cannot count using big data, right? Because the complexity is from n squared with a log n to the worst is the n triple, right? N cube, right? So these are advantage and disadvantage. And then still the thing from our machine learning engineer, we need to know here is that how we determine the model, how we design the model, and then we need to know how this model doing. Is good or not good, is bad. So it will introduce, the next step is the cluster evaluation, right? So just today we will introduce the random index. Random index, you can say, is Ri, right? So Ri is actually means the let me say the percentage of same pair. Let me do the so it will from 0 to 1, yeah. So let me do an example. Example will be better. So for example, we will have our clustering result and a true label result, right? And here, when we do the evaluation, we may need, we can need or no need the true label, but here the random index is in need the label, external label to evaluate it. right? So let's say C is mean the clustering result, and T is the true result. Let me use a red and blue. C and T, okay? So C, I will say C with A, B, C group, and D and T also have A, B, C group. And what we want to cluster is the A, B, C, D, E. Okay, it's a simple example. So for our clustering, I say AB is in cluster A, and CD is cluster B, and E is in cluster C. And our true label is like CD is in cluster A, and AB, let's say E is in cluster B, AB is in cluster C. So how about their RI? The RI? The RI should be 1. So let's back to our random index, rand index, RI. It means the percentage of, actually not the same pair, is the accuracy of pair assigned. Let me do an example. Yeah, we can say there are some ABCD, let me use, these are points, okay? ABCD. And our clustering result and a true labeled result. So A should be cluster, I am clustering to be 1, cluster 1, cluster 1, and cluster 2, and cluster 1. And the truth is, it should be cluster 1 and cluster 1 and cluster 2 and cluster 2. So when we we can draw a table or the pair, right? You can say AB, we will get how many pair we can have. So we will have pair is like C42, right? 4, 3. But remember, we need to divide it by 2. So there is 6 pairs. So we will have AB, AC, AD, BC, CD. Oh, BD, CD, right? So those are pairs, and we will say, is it the same group? Same group. Or is it the same group in clustering? And is it the same group in true label? So AB, yes, it's the same. And sure, it's true in the true label. AC is not the same, and it's also not the same in the true label. AD is the same in our clustering, but it's not the same in the true label. BC is not the same in cluster and not the same in true label. BD is the same in clustering and not same in the true label. CD is not the same in clustering but same in the true label. And then we will generate, is it these two guys the same? Same cluster and T assign or not? So we will say, we can get that. True is true, yes. False is true, yes. True false is false. False is true, and true false is false. False true is false. So we will generate that it's about 3 of 6, the accuracy of 3 of 6. So this guy will be our RI. Okay? That is how the accuracy is that these two, the pairs are assigned the same with in our clustering model and true label model. Yeah. And I think it should be a what? It should be a AND gate, right? True is true. False is false. Sorry for the interruption. And here we will say the normalized mutual information. So for simplicity, it will say MNI. And here is the example, right? We will want to cluster the ABCD, E point, and C, it means our clustering model, the result of the clustering model, and T represent the true label, the true clustering result. So the result we get here is that we say AB point is in A class or A cluster in our clustering model, and so that's so the AB, the CD, the E, and for the true we said CD points are in A cluster and E is in B, AB is in C, right? So the RI result should be 1. Why? Because we just need to know is that CD can be set into the same group. Okay, I would say group instead of cluster. That will be easy. So sure, because initially in our clustering model, it is set into the same group, and AB is also in the same group, and E is in the same group. I mean, it's in a group. That means I capture the relationship between these 2 points, right? Between these 2 points, between the points. So the not RI, sorry. The MMI is 1. Yeah. So we are not caring which group it says. It can be A or it can be B. We just want to know these 2 guys is in the same group. So yeah. Okay, let's talk furthermore about the NMI. So for the formula here, it's actually using these 2 things. One is the entropies, and the other is the mutual information. So entropies we use it a lot of time, and it's just the probabilities calculation, and also the mutual information also using this kind of the probabilities. That means the PIJ means the probability that a specific item that is both in the I cluster in one clustering and in the J cluster in the another clustering. Yeah. So let's do the example. Since the example here is not that, it is too ideally, I will try to change a little bit. Okay, change what? Change it into CB and AD. All right. Okay, and then we will have the table with the A cluster, B, C, A, B, C, and here is representing in the is the true, and here is the our model. Okay. Okay. So like when we are saying A, and we have the items, right? A, B, C, D, E. The A belongs to cluster A in our model, and it should be cluster C in the true model, true label, true cluster. Okay, and we're doing the same thing. B is in the A group in model C and should be in the also in the A group in the model T, and C is in the B group in model C, and A group in the is C, and A group in the model T, and D is in B group in model C, and C group in model T. E is in the C group in model C, and B group in model T. Okay, well, so based on these informations, we can first calculate the entropies. Okay, that means you randomly pick any item. Does it the probabilities that belongs to these clusters? So like for our A row, the probability should be 2/5, right? And B is 2/5, and C is 1/5. And we also can do another calculation thing, the probability things, right? So remember here, this kind is for the true group, and these kind of things belongs to our C group. Okay, so based on these two, we can calculate the H. I mean the HC and HC prime, or HT. Okay, and then we want to actually we can also give the PI and PJ. Okay, so and also we need to know the PIJ, right? The PIJ. Need the PIJ to calculate the actual probabilities of the mutual information. So how about the PIJ? Actually, we the only PIJ we can get is the PAA, right? This one, and PAC, PBA, PBC, and PCB. Yep. And we just have these 5 kind information in our table, right? So their mutual probabilities, or how to say these kind of probabilities. I mean, there will just be simply how many items inside this block out of all items, right? So there are 1B in the AA, right? And we have 5 items, so actually it should be 0.2, right? And also other blocks are doing the same thing, so all of them are having 0.2 as their union probabilities, I think, right? So the union probabilities here will be 0.2 for everyone. Okay, so till now we are getting all information we want, right? The union probabilities, the probabilities for each cluster in each clustering model, and then we can calculate the mutual information, and also the entropies. And using these 2 things, we can calculate the normalized mutual information. Yeah, I think that's the calculation things.